While two-phase systems are becoming less common, they are still in use in some applications. Therefore, it is not appropriate to remove all references to them from the National Electrical Code, or NEC. However, it is agreed that the current NEC language on two-phase systems could be improved. Here is a suggestion to create a separate section to address these systems, and that the language be simplified and clarified. It would entail adding a new section 999 to the NEC titled Two-Phase Systems. This section would include all of the existing NEC rules on two-phase systems, but would be rewritten in a clearer and more concise manner. The section would also include a new requirement that all new two-phase systems must be installed in accordance with the requirements of the section. This proposal would address the concerns raised, while still ensuring that the NEC provides adequate coverage of two-phase systems. To elaborate on why two-phase systems, though less prevalent, still warrant consideration, let's delve into their characteristics, applications, and the implications of their potential removal from or modification within the NEC. Firstly, understanding what constitutes a two-phase system is crucial. In essence, it involves two alternating current, or AC, voltages that are out of phase with each other, typically by 90 electrical degrees. This phase displacement distinguishes it from single-phase and three-phase systems, which are more commonly encountered in modern power distribution networks. The historical context of two-phase systems reveals their significance in the early days of AC power. They were employed in various industrial applications, particularly in motors and generators. While three-phase systems eventually gained dominance due to their superior efficiency and power handling capabilities, two-phase systems persisted in certain niche areas. Secondly, the applications where two-phase systems are still found are often legacy installations within older industrial facilities. These systems might be powering specific types of machinery or equipment that were originally designed to operate on two-phase power. Replacing these systems entirely can be costly and disruptive, leading some facilities to maintain them rather than undertake a complete overhaul. Furthermore, certain specialized applications, such as servo motors and control systems, might still utilize two-phase power for precise control and responsiveness. The reasons for retaining references to two-phase systems in the NEC stem from the code's fundamental objective to ensure electrical safety. Even though these systems are less common, electricians and electrical engineers may still encounter them during maintenance repairs or renovations of older buildings or industrial sites. Without clear guidelines and regulations, there is a risk of improper handling, potentially leading to electrical hazards such as shocks, fires, or equipment damage. The NEC serves as a comprehensive resource for safe electrical practices, and its coverage extends to a wide range of systems, including those that are not as widely used. Thirdly, the argument for simplifying and clarifying the NEC language on two-phase systems is valid. The existing wording may be outdated or difficult to understand, especially for those who are not familiar with these systems. By rewriting the relevant sections in a more concise and accessible manner, the NEC can improve its usability and reduce the potential for misinterpretations. A separate section dedicated to two-phase systems could also help to consolidate the information and make it easier to locate within the code. The proposal to add a new requirement for all new two-phase systems to be installed in accordance with the NEC addresses a potential loophole. If the existing language is ambiguous or incomplete, there is a risk that new installations might not meet the necessary safety standards. By explicitly stating the requirements for new two-phase systems, the NEC can ensure that these installations are performed correctly and safely. The potential benefits of retaining and revising the NEC language on two-phase systems outweigh the perceived drawbacks. While it is true that these systems are becoming less common, they still exist and pose potential safety risks if not handled properly. By providing clear and up-to-date guidance, the NEC can protect electricians, electrical engineers, and the public from harm. The proposed compromise of creating a separate section dedicated to two-phase systems represents a balanced approach. It acknowledges the need for simplification and clarification while ensuring that the NEC continues to provide adequate coverage of these systems. This approach aligns with the NEC's overall mission to promote electrical safety and advance the state of the art in electrical practices. In addition to the points already discussed, it is important to consider the impact of removing references to two-phase systems on electrical education and training. Electrical apprentices and students need to be aware of the existence of these systems and their characteristics, even if they are not likely to encounter them frequently in their careers. By including information on two-phase systems in the NEC, the code serves as a valuable educational resource. It helps to ensure that future generations of electricians and electrical engineers are equipped with the knowledge and skills necessary to work safely on a wide range of electrical systems. Furthermore, the NEC coverage of two-phase systems can facilitate research and development in related areas. While these systems may not be at the forefront of innovation, there may still be opportunities to improve their efficiency, reliability, or safety. By providing a comprehensive reference point, the NEC can support these efforts and contribute to the advancement of electrical technology. The decision to retain or remove references to two-phase systems in the NEC ultimately involves weighing the costs and benefits. While there may be some cost savings associated with removing the language, the potential safety risks and educational implications outweigh these benefits. By retaining and revising the language, the NEC can continue to fulfill its mission of promoting electrical safety and advancing the state-of-the-art in electrical practices. It is also worth noting that the NEC is a consensus-based code, meaning that it is developed through a process of collaboration and input from a wide range of stakeholders. This process ensures that the code reflects the collective knowledge and expertise of the electrical industry. The decision to retain or remove references to two-phase systems should be made through the same consensus-based process, taking into account the views of all interested parties. In conclusion, while two-phase systems are becoming less prevalent, they still warrant consideration in the NEC due to their presence in legacy installations, specialized applications, and the need for electrical safety. Simplifying and clarifying the existing language, along with creating a separate section dedicated to these systems, represents a reasonable compromise that addresses concerns while maintaining adequate coverage. This approach aligns with the NEC mission to promote electrical safety, educate future generations of electricians and engineers, and support research and development in the electrical field. The NEC should continue to evolve to meet the changing needs of the electrical industry, but it should also maintain its commitment to providing comprehensive guidance on a wide range of electrical systems, including those that are not as widely used. To provide a more detailed overview of the characteristics, applications, and potential hazards associated with two-phase systems, let's delve into specific aspects. Firstly, the phase relationship in a two-phase system is typically 90 electrical degrees, as mentioned earlier. This means that the voltage waveforms of the two phases are offset by 1/4 of a cycle. This phase displacement is what allows two-phase motors to produce a rotating magnetic field, which is essential for their operation. In contrast, single-phase systems do not have this phase displacement, which limits their ability to produce a strong and consistent rotating magnetic field. Secondly, the voltage levels in two-phase systems can vary depending on the application. In some cases, the voltage may be the same as that used in single-phase systems, such as 120 volts or 240 volts. In other cases, the voltage may be higher, such as 480 volts or even higher. The voltage level is chosen based on the power requirements of the equipment being served and the distance over which the power needs to be transmitted. Thirdly, the wiring configurations used in two-phase systems can also vary. One common configuration is the two-phase 3-wire system, which consists of two-phase conductors and a neutral conductor. Another configuration is the two-phase 4-wire system, which consists of two-phase conductors, a neutral conductor, and a ground conductor. The choice of wiring configuration depends on the grounding requirements and the need for a neutral connection. Fourthly, the types of equipment that are commonly powered by two-phase systems include motors, generators, transformers, and control systems. Two-phase motors are often used in applications where precise speed control is required, such as in servo motors and machine tools. Two-phase generators are used in some older power plants and industrial facilities. Two-phase transformers are used to step up or step down the voltage levels in two-phase systems. Two-phase control systems are used in a variety of applications, such as robotics and automation. Fifthly, the potential hazards associated with two-phase systems include electric shock, arc flash, and fire. Electric shock can occur if a person comes into contact with a live conductor or a grounded object. Arc flash can occur if there is a short circuit or a fault in the system resulting in a sudden release of energy. Fire can occur if the system is overloaded or if there is a loose connection. To mitigate these hazards, it is essential to follow safe electrical practices and to use appropriate personal protective equipment, or PPE. This includes wearing insulated gloves, safety glasses, and arc-rated clothing. It is also important to ensure that the system is properly grounded and that all connections are tight and secure. In addition to these general safety precautions, there are some specific considerations for working on two-phase systems. Firstly, it is important to identify the phase conductors and the neutral conductor before working on the system. This can be done using a voltage tester or a multimeter. Secondly, it is important to energize the system before performing any work on it. This can be done by opening the circuit breaker or disconnecting the power supply. Thirdly, it is important to use insulated tools when working on the system. This will help to prevent electric shock. Fourthly, it is important to follow the NEC guidelines for working on two-phase systems. This includes the requirements for grounding, wiring, and overcurrent protection. By following these safety precautions and guidelines, it is possible to work safely on two-phase systems and to minimize the risk of electrical hazards. The NEC serves as a valuable resource for safe electrical practices, and its coverage extends to a wide range of systems, including those that are not as widely used. It is important to consult the NEC before performing any work on an electrical system, regardless of whether it is a single-phase, two-phase, or three-phase system. The NEC provides detailed information on the requirements for grounding, wiring, overcurrent protection, and other safety aspects. By following the NEC guidelines, it is possible to ensure that electrical systems are installed and maintained safely and reliably.